Today, I want to talk about something that many AI teams might underestimate. That is how to scale evaluation. Not just score models, not just run benchmarks, but how to make evaluation scale across hundreds of features, staggered locations, and evolving models. So let me summarize the core idea. Scale and autonomy makes manual evaluation impossible. If every feature team writes their own prompts, choose their own metrics, applies responsible AI checks slightly differently, you lose consistency, you lose comparability, and you lose trust. So I propose treat evaluation as a governed platform infrastructure, but a governance alone isn't enough. The key is metadata-driven orchestration. That is what makes it scalable. And responsible AI isn't just a checklist. It is a structurally enforced inside the orchestration layer. And large scale evaluation falls in four ways. Feature specific evaluation doesn't generalize. Large language model is charged, increase throughput, but introduces drift. Prompt evolves uniformly over time. Risk enforcement becomes inconsistent across teams. The deeper issue is this. Evaluation today is treated as content, but it should be treated as code. Without a governed evaluation layer, you cannot compare across time, across features, or ensure consistent ROI enforcement. So the bottleneck is architectural, not human. Scalability starts with abstraction. Quality is not universal. A summarization model may feel different from a creative generator. A translator feature feels differently from a personal assistant. So instead of writing evaluation logic per feature, we can define canonical feature category. Each category defines what metrics are valid, what risks are dominant, and what responsible AI gates are required. So for example, summarization, we can focus on faithfulness, coverage, and hallucination avoidance. And for translation problems, we can focus on semantic equivalence and cultural alignment. This taxonomy becomes a foundation for reuse. When a new feature launches, we don't invent evaluation from scratch. We map it to a category and inherit its validation contract. And also be noted that we need to provide a controlled customer category for novel and emergent feature types, which happens pretty often today. Feature design to this category must explicitly declare their evaluation metrics and subject to mandatory responsible AI enforcement, ensuring that innovation doesn't bypass security check. The three design principles make this scalable in practice. So first, auditability and traceability. Every evaluation prompt is versioned. Every matrix is explicitly defined. Every output is structured JSON. This makes the evaluation reproducible. Second, structural responsible AI enforcement. Safety, privacy, and bias are not optional scoring dimensions. They should be hard gates embedded in this template. And third, cost-aware orchestration. Scalability is not just technical, it's economic. If every evaluation requires multi-step agent reasoning, cost becomes a bottleneck, so we separate deterministic and agent modes. This is a core architecture design. We intentionally built two modes. Template mode is pure Python. It is deterministic, no dynamic reasoning. It's fast, predictable, and essentially free to run at scale. Agent mode is built on the Microsoft Agent Framework. It can use tools, it has memories, it has dynamic decision. So why do we need both? Because scalability has two dimensions. One is operational scale. Handling massive volume, that is template mode. Another part is complexity scale. It handles novel, ambiguous tasks, then that's agent mode. In other words, template mode handles volume, agent mode handles novelty. And you know, determinism protects the system, but agent autonomy improves the system. And the real production system evolve over time, right? So we'll start with two modes: monitor performance and feedbacks, need data guide how each other expects or hybrid. And stability is the foundation, and intelligence is the accelerator. And here the slide shows how scalability becomes mechanical. We don't manually write prompts. We assemble them based on feature metadata, category and no-kill resolution, matrix selection, RI injection, JSON output enforcement, and each template has a fixed structure, like evaluator role, hard fail gates, primary matrix with weights, second order single, evaluation protocol, responsible AI checklist, structure output format. And hard gates overrides everything. Let's say if privacy or safety fails, the feature fails, regardless of the matrix average. So this makes risk enforcement scalable and consistent. When a feature is new or ambiguous, determinist rules may not be enough. Agent mode introduces goal-directed reasoning, as the agent can look up relevant metrics, suggest additional ones, detect architecture types, retrieve no-kill regulatory information, validate responsible AI compliance, construct updated evaluation prompts. And importantly, it uses tools it handles its structure. It makes it adaptable but still governed. And this comparison makes a trade-off clear. With the agent-generated prompt, you get 20 plus evaluation metrics, very fine-grained reasoning, high transparency, but also comes with higher cognitive load. It is ideal for research, deep diagnostics, and retaming, where you want maximal insights. With a template prompt, you get a focused set of core metrics, stable, repeatable outputs, clear operational logic, strong automation readiness. So the right choice depends on the scenario. If you need stability at high volume, use a template. If you need the depth and adaptability, use an agent. In many real-world systems, the best solution is hybrid. There's a template head or the bulk automation, and then the agent stepped in when human judgment or deeper reasoning is required. It's not either or, it's about designing the right balance. So yeah, this is where governance meets scalability. Responsible AI exists at three structural layers: privacy protection, bias and safety enforcement, hallucination detection. These are not advisory, they are embedded. So for example, if a translation leaks PII, automatic fail. If a summary invents medical advice, automatic fail. As the product gets to new markets, no-kill specific RAI requirements are ingested automatically. Trust scales with product growth. Yeah, I'll demo the MetaFeature Orchestrator web that I built by myself in another video with tons of examples. Um, and I only close this talk with 3 points. So first, evaluation must scale horizontally across features and no kills. Second, it must scale vertically across complexity, including agentic system. And third, it must scale economically and operationally across teams. A MetaFeature Orchestrator turns evaluation from a manual bottleneck into governed, scalable infrastructure. Because as AI systems become more autonomous, evaluation must become more architectural. Thank you for watching.